Hello, my name is Carlos Molina. Welcome to my air quality prediction based on weather presentation. It was created as part of the IBM Coursera Advanced Data Science Capstone project. Data science is about obtaining and transforming data to provide useful information. For this project, we use historical information about weather and air quality from Madrid, Spain. In my opinion, if we can anticipate a poor air quality situation based on the forecasted weather, that can be very helpful. Both data sets are free and they were obtained from Kaggle. Here is Kaggle's webpage. As air quality is measured every hour and weather is measured daily, we obtain the daily average information for air quality from 2001 to 2015. Air quality data sets contains the station identifier, the date and time on which measures were obtained, and the level measured of several pollutants. Weather data set contains the date and several variables related with temperature, humidity, visibility, precipitation, and wind. The air quality can be measured based on the level of some particular pollutants. Common information to European air or site air provides the guidelines to calculate the pollution level. Pollution scale is divided in very low, low, medium, high, and very high. Pollution level is determined by the highest scale value of all the considered pollutants. If any pollutant has a grid value greater than 100, that is considered a very high pollution and a risk for health. These are measured pollutants and their effects to the human health. However, site air considers only the ones highlighted in yellow. These are the other measured pollutants. None of them were included in calculations. These are all the variables in the weather data set. Air quality levels were calculated for all the considered pollutants and 2 additional columns were added. Air quality max with maximum value of grid of pollution and air pollution level with values from 0 for very low to 4 for very high. This slide shows an example of the 2 additional columns. Air quality max was associated with NO2. For rows 1 and 2, values were less than 25, so pollution level was 0 or very low, and for rows 3 and 4, values were greater than 25 and less than 50, so pollution was 1 or low. Once all the calculations and summarizing were completed, final data set had 5,462 rows and 20 columns. How this model could be applied? If we have weather forecast information in advance, we could predict lower quality situations in the near future. That could help city government to communicate and coordinate actions to mitigate the impact of pollution. Next, we will review the prediction models and their accuracy. We evaluated 5 machine learning algorithms: linear and radial support vector machine, logistic regression, k-nearest neighbors, and decision tree. We also used the random forest classifier to determine the importance of each of the variables in the prediction results. Data set is divided in training and testing data sets. Training helps to estimate the prediction model and testing to evaluate if predicted values are equal to actual values or not. Models with most accurate predictions had about 74% of correctly predicted results. As this exercise is related with time series, we used a recurrent neural network algorithm called long short-term memory or LSTM. This model predicts floating numbers. To evaluate how precise are predictions, we use an indicator called mean square error. Training dataset can be divided in batches, and each complete pass on the training dataset is called an epoch. By estimating the mean square error with different batch sizes and number of elements in the training dataset, a set of values of batch size and training items were obtained to minimize the mean square errors. Those were 31 of batch size and 4,753 in training items. Mean square error was around 0.065 for training dataset and 0.055 for testing dataset. The final graph is reshaped to have the values from 0 to 1, and it shows the comparison of pollution level against actual values. In most of the cases, they are not far from each other. To be able to compare the accuracy of neural networks against machine learning, the pollution levels of breed were calculated for the predicted and actual values. From 708 predictions, 625 were correct. So the approximate accuracy of neural networks was 88%, which is better than the 74% of machine learning. Thank you for watching this presentation, and I hope you enjoy learning about data science. Hello, welcome back to the technical part of this presentation. We are going to review architectural choices selected for this project. As this project is only for analysis purposes, we selected data source and discovery exploration components only. Volume of information is less than 500 megs, and total records in the air quality data sets is less than 4 million. Neither it needs extensive data processing. IBM Watson Studio and free resources from IBM Cloud were enough for this project. In this section, we are describing how the data set was obtained and prepared for processing. Some of the records were missing pollution measures. Most of them were estimated with the mean of the available resources. For the ones still missing, the previous ones were used. Once daily air quality information was obtained for each year, all was combined into a single pandas data frame. This data frame was joined with the weather one. Two additional columns were added to help determine the daily pollution level. Those were air quality max and air pollution level highlighted. How precise were the predictions of the evaluated models? Accuracy is the number of correct predictions in the test data set divided by the number of samples of the test data set. Random forest allows to determine what are the variables with more influence in the results of the prediction. Accuracy was calculated for all the variables considered, also for the most 4 important variables. Value obtained was approximately 74%. Long short-term memory, LSTM, recurrent neural network is frequently used in time series predictions. Graph shows predicted versus actual values. You can see that they are near from each other. As predictions and observations are non-integer values, the integer values of pollution level was calculated in the predicted and actual values to determine accuracy. It was 88% approximately. The following slides describe how the LSTM selected algorithm was applied. Null values were replaced with previous readings to avoid records to be executed for processing. Dataset series were converted to supervised learning array, and values were rescaled from 0 to 1. With an iterative process and different number of training and testing samples. Also training samples divided into different number of batches, the value that minimizes the mean square errors and therefore makes prediction more precise was obtained. This was a batch of size 31 and 4,753 training items. I would like to share some resources that I found useful. First, I would like to thank to Romeo Kinsler, instructor of this and other IBM Coursera data science courses. There are a lot of resources available in his Coursera GitHub repository. I would like to thank IBM as well, that provided free resources for learning, collaborating, and hands-on practicing, and encouraged to learn about data science. Kaggle, as we saw in the first presentation, contains several tutorials, blog, code samples, and data sets. Jason Brownlee provided a tutorial with multivariate time series forecasting with LSTM and Keras. Thank you for watching. Keep learning. See you next time.